Alright, we want to take a look at those practice problems on page 74. Just do a quick walkthrough, make sure you guys are doing okay. So number 74, or from page 74, number 42 says, a construction worker accidentally drops a brick from a high scaffold. What is the velocity of the brick after 4 seconds, and how far does the brick fall during this time? Okay, so I don't know a whole lot. I know it starts up here. Here's a brick. And it's dropped from a high scaffold, so that lets me know initial velocity is 0. Final velocity, I don't know. I'm asked to find that. Acceleration equals what? Well, I'm going to call this way down, so negative, so negative 9.8 because it is a free fall problem. Okay, so that's basically what I know. Okay, and it says for part A, what is the velocity of the brick after 4 seconds? So at t equals 4 seconds, I'm supposed to find v. So v equals v naught plus at. So this just equals 0 minus 9.8 times 4, which equals negative 39.2 meters per second. Okay, so it's falling down at 39.2 meters per second. How far does the brick fall during this time? So change in position, and since it's a vertical position, I'm going to use y equals 1/2 at squared plus v naught t. Okay? And so this equals 1/2 9.8, and I put the negative out front because it is down, times 4 squared plus 0, which equals negative 4.9 times 16, which equals 78.4, negative 78.4 meters. Okay, so it fell negative 78.4 meters in 4 seconds, and by the time it had fallen that far, it was moving at negative 39.2 meters per second. Alright, 43 says, what if we did the exact same thing, but we chose the coordinate system so that the other way was positive? Okay, so if this becomes positive, then my acceleration's positive, and instead of negative, and so all that does is it changes this negative to a positive and this negative to a positive. So instead of moving at negative 39.2 meters per second, we'll be moving at positive 39.2 meters per second. And instead of having a negative velocity of 78.4, we'll have a positive velocity. So all that happens is we reverse the sign. Okay. 44. A student drops a ball from a window 3.5 meters above the sidewalk. How fast is it moving when it hits the sidewalk? So I know an initial velocity, it's dropped, so 0. I'm trying to find its final velocity. I know it changed in position, negative 3.5 meters. Okay, and it's negative because I almost always choose down to be negative, which means my acceleration is also negative 9.8 meters per second. Okay, and I'm supposed to find final velocity, and so we can just say third equation, final velocity squared equals initial velocity squared plus twice the acceleration times the change in position. And so I'm going to have this equals negative 19.6 times 3.5 squared, or not 3.5 squared, just 3.5 times negative 3.5. Okay? And when we do this, we're going to end up with a positive, which is good because I need to square root it, but we have to pay attention to our direction, right? So I end up with v squared equals 68.6. So I square root that, and v 8.3 meters per second, but since I chose down to be negative, this has to be negative. Remember, the square root is plus or minus, and you got to pay attention to that. Okay. 45 says a ball is thrown straight up with an initial speed of 22.5 meters per second. It is caught at the same distance above the ground. How high does the ball rise? How long does the ball remain in the air? Okay. So how high and how long are my two questions. So I'm looking for a height and I'm looking for a time. But these are two different questions because remember, the motion of the ball, it goes up, comes back down. Okay, this is how high, and that's only half the interval. This is how long, and that's the whole interval. Okay, so let's start with part A. How high does it go? I know my initial velocity is up, and it's 22.5. And since up is generally chosen to be positive, I'm going to leave this as positive. Acceleration, it is gravity, so negative 9.8 meters per second. And the other thing I know about this is when it's at its highest point, when it's changing direction, its velocity is 0. So I can get my information, and now I need to go ahead and use that. And I'm trying to find when the final velocity is 0, how high is it? And I can say the final velocity is 0 at its highest point because it's changing directions. So I know an initial velocity, I know a final velocity, I know an acceleration, and I want to know time. So I'm going to use the third equation. V squared equals V naught squared plus twice the acceleration times the change in position. Okay? So 0 equals 22.5 squared plus 2 times negative 19.6 times delta y. Alright, so 22.5 squared is a fairly large number. 506.25, and I'm going to go ahead and move it over. So negative 506.25 equals negative, I already multiplied that, 19.6 delta y. Divide both sides by 19.6, negative 19.6, and I get 25.8 meters. So I know at its highest point it was 25.8 meters above where it started. Okay. Part B says how long is it in the air? Well, now I can use the second equation. I can say y equals 1/2 at squared plus v naught t plus y naught. Okay. And I know its final position is 0. Right? It ends where it starts. I know negative 4.9 half g t squared plus 22.5 t, and plus initial is 0, so I'm going to leave that out. Okay, so I can divide everything by t and add this over, so I get 4.9 t equals 22.5, and then all I have left to do is divide 22.5 by 4.9, and I know that the time the ball was in the air is about 4.6 seconds. Okay. So, part A, part B. Alright, 46. You decide to flip a coin to determine whether to do your physics or English homework first. The coin is flipped straight up. If the coin reaches a high point of 0.25 meters above where you released it, what was its initial speed? And if you catch it at the same height as you released it, how much time did it spend in the air? So 46 is a heck of a lot like 45. It's just asking us to do a little bit backwards. So initial velocity this time is unknown. Okay? But for part A it says it reaches a high point of 0.25 meters. Okay, so I know a delta y. I know how high it goes. It goes 0.25 meters. I know its final velocity when it gets there. At its highest point, it's not going up, it's not going down. And I know the acceleration is negative 9.8 because I chose its change in position to be positive. So, final velocity squared equals initial velocity squared plus 2 times negative 2a, right? And so there's the third equation, delta y. Alright, so 0 equals v naught squared plus 2 times negative 9.8 times 0.25. Okay? So v naught squared equals negative 4.9, except I'm going to move this over, so negative v naught squared equals negative 4.9. And so now I've got a negative on both sides, so it's gone, so I can square root, and v naught equals the square root of 4.9, which is 2.2 meters per second. Okay? And it is positive because we did flip it up. Okay. Part B says, all right, how long is the coin in the air? We know our final velocity, we know our initial velocity, or we know we're starting and ending positions. So again, I'm going to use the first equation, v equals v naught plus at. Okay. Now this is only going to work for the first half because I'm going to say my final velocity is 0, so it's at its highest point. My initial velocity is 2.2, I just calculated that, plus negative 9.8 t. Okay. Now what this is going to allow me to do is calculate the time it takes for that thing to rise. So I'm going to take 2.2 divided by 9.8, right, because I can move that over, and I get t equals 0.22 seconds. Okay. That's the time that it takes to go up. It's a symmetric curve, so it takes an equal amount of time to fall back down, so the total time is actually twice that, or 0.44 seconds. Okay. You could also use the second equation and solve for t.